Hi everybody. Today we're going to go over lesson 5, parent functions, transformations. My hope is that you have a pretty good working knowledge of them based on what you learned in algebra. So let's get started. Linear parent function, y equals x. My hope is that you know it looks something like this. Passes through 0, 0. Rise 1, run 1, has a slope of 1. So basically as a line through the origin 0, 0 with a slope of 1. Now, if you didn't know that, okay, here's what you do. Take the equation and plug in. So if y equals x and x is negative 2, y is negative 2. If y equals x and x equals negative 1, then y is negative 2, and 0, and 1, and 2. So basically you're just plugging all of these all of these x values in to solve for your y value. That is another way you could have gotten these coordinates on this graph, like 2, 2, negative 1, negative 1, but that's the basic idea. Next one, quadratic parent function. Quadratics are those that have a highest power of 2. So we have y equals x squared as your parent function. So to find your y's, just square. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared, 1 squared, 2 squared, and then you graph. So you got the origin, 1, 1, 2, 4, negative 1, 1, negative 2, 4, something like that. And what about it? Well, it's a parabola. With vertex at 0, 0, and it is also concave up. Cubic. So that would be the equation y equals x cubed. So filling in the points, negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 cubed, 1 cubed, 2 cubed. So it looks something like this. 0, 0, 1, 1, 2, 8. So it rises as you go left, falls as you go right. So putting it in words, it actually has something called a point of inflection at the origin, and it rises left. Sorry about that. It rises right, excuse me. As you go to the right, it rises and then falls as you go to the left. It is an increasing function in that as you do go right, the value of as x gets larger, so does the y. Okay. Absolute value we've talked about a little. It's y equals absolute value of x, which marks your distance from 0 on the number line. So negative 2 is 2 units from 0 on the number line. 1 unit, 0 is 0 units. 1 and 2. And looks like a V. So what are its characteristics? Well, it's V-shaped. I don't know if you want to call this a vertex. I suppose you could. As a vertex at 0, 0. And this one does open upward. Okay, and the last one, y equals square root of x. Square root of -2 is undefined, so is -1. 0, square root is 0, square root of 1 is 1. Square root of 2 is like 1.414 and change, but, or you can just call it root 2 if you prefer. And it goes something like that. First thing I do know is that it starts at 0, 0. It is an increasing function. And its domain only goes from, in brackets, 0 included, to infinity. All of these other ones that we've done so far, the linear has a domain -infinity to infinity. The quadratic has a domain of -infinity to infinity. The cubic, same thing. Domain -infinity to infinity. Same with the absolute value function. The only one that doesn't is our friend there, the square root function, and basically because hopefully you learned that you cannot take the square root of a negative number. Okay, so the next thing we're going to do is I want to talk about the vertex form, or you can call it the transformation form, if you will, of a function. That's y equals the parameter a times some function f of x minus h plus k. You say, well, what's f? Well, the f could be your linear function. It could be your absolute value function. It could be your parabola. It could be your cubed. It could be your square root function. It could even be like a sine function, you know, like the sine of x or the cosine of x. The f can be pretty much any function, and you're going to find these transformations kind of hold true all the way through. So how does the parameter a? So let's notice where the parameter a is. It's right there in front of whatever function I have. So let's go ahead and take a good look at it. So I want to experiment a little bit, and then we'll talk. I'm going to go ahead and hold that thought. I'm going to start with a parent function. I'm just going to go with the absolute value function of x. I'm going to keep that as blue. And then here's what I'm going to do. I'm going to put some a values in there, and let's see what happens. So what if I do 2 times the absolute value of x? Let's see what that does. So here's your parent function, the absolute value. There's 2 absolute value in the red. Well, you know what? I wonder what happens if I do 3 absolute values of x. And again, these are all different colors. I think I see a pattern. Let's do one more. Let's do like 5 absolute value of x. And let's see how this pink one or whatever is different than the others. Okay, so what it seems like is happening here is that the bigger that these numbers get, these coefficients in front, these parameters, like your a values, the bigger they get, 2, 3, 5, the narrower that gets. We actually call that a vertical stretch, meaning it rises faster. The y values get bigger faster. That's a vertical stretch. So then, how do you suppose I would get a vertical compression where it's not so steep? I know people say, well, let's do this. Let's put some negatives in front. So, all right, so let's go with like negative absolute value of x. And let's see, does that make it less wide, or does that make it where it's not stretched but compressed? So here's your parent. No, the negative did not do that at all. It made it it made it reflect. Well, what if it's -2? All right. So here's your original. Here's your parent function. No, it looks like it got narrower, or like a vertical stretch, and it didn't compress it. So let me see here. Let's get out of here for a second and go back and do a little writing here. So, how does the parameter a affect the graph of the parent functions? Well, the first thing I'm noticing is that if a is negative, like less than 0, what that means is that you're going to have a reflection across the x-axis. I noticed that if a was greater than 1, that it got narrower, that it did that vertical stretch. So let's see what else we can do then. Let's see if we can get this compression now. So I'm going to go back to my calculator. And this time I'm going to take like something like this. I'll take like 1/2 absolute value of x. So here's my original, here's my parent function. Okay, so it did get wider. It did do a vertical compression. Okay, let's see if we can make it even wider, even more compressed. Let's try like 1/4 times, oops, let's try that again. 1/4 absolute value of x. And it got even wider, it got even more compressed. So basically, the closer your a value gets to 0, the wider or the more compressed it's going to get. So as a gets close to 0, what you'll notice is that the lines on the absolute value, or it would be the same thing for like a parabola or whatever, they seem to be getting close to the x-axis. And then if I take it and make it a bigger number, like say 7 times the absolute value of x, come on, there you go. So as the number in front gets bigger, they get narrower, it's a stretch, it gets closer to the curves, or the graph gets closer to and like hugs the y-axis. So that's a pretty good start into what the a does. So let's try that. So basically, if a is somewhere between 0, oops, hold on. So if it's greater than 0 but less than 1, that's when you get that vertical compression. Again, I cannot emphasize this enough. As this parameter A gets closer to 0, number one, it's going to make your graphs a lot wider, and it's going to get closer and closer to the x-axis. As this parameter A gets bigger, like 5, 7, 100, it stretches and your graph gets closer to the y-axis. Okay, so let's do the next one. The K is probably one of the easier ones to do. And again, notice where the K is. K is just being added onto the end, so let's take a couple. I'm going to get rid of all of these bums. So let's take our same absolute value of x. So let's put like a +2 on the end here. That's what your K is, and what does it do? Okay, here's your parent function. Let's compare the transformed. It looked like it went up 2 units. All right. So then what happens if I take that same, that same absolute value graph, only this time, let's put +5 on it. Okay, and by examining the graphs, it looked like that vertex, or that point where the two lines meet, went up 5. So how do you suppose I make it go down 3? Well, let's try this. If I go absolute x -3, and notice, I did not put the -3 inside with the absolute value. That is a key point. And sure enough, it did move it downward. Okay, so I think I got a pretty good handle on what the K does. The parameter K is actually called the vertical shift. It will move up if K is positive. It will move down if K is a negative number or is less than 0. Okay, then the H. This is the one that tends to give people the most trouble. What does that parameter do? Well, we've stretched it, we've compressed it, we reflected it. That's what this does. We moved it up, we moved it down. That's what the K does. Let's see what the H does. So, again, I'm going to go back to the calculator. I'm going to get rid of all of that. I just got rid of the parent function. That's okay. Easy to fix. Again, I like showing the parent function on the calculator so you can see where it was initially and then how it changed. So there's my parent function. So inside, I'm going to put an absolute value of x, but this time for the h, you're going to find it inside. Now, I'm going to put h minus 2 without that 2 there. Now, a lot of people say, okay, so since you put a -2, that's going to mean it moves to the left, because -2, -2, that's a number that's on the left side of a number line. Makes sense, right? It does, except it actually moves it to the right. Oh, well, what if I do an absolute value? And again, I'm using absolute value here. I could have easily chosen parabolas, the cubics, any of those parent functions, and it would have been just fine. So then, if x minus 2 moved it 2 units to the left, or to the right, does x minus 4 move it to the right? 4 units? It does. So then, what do I do to move it to the left then? Well, let's put a plus here. And let's see if that moves that +2 to the left this time. And it does. Okay, this sounds like a good time to do a little talking here. So, I know number one, this is called a horizontal shift. So I know it does move it to the left and to the right. So here's the idea. Let's go back to this equation. Again, the parent function I had was y equals absolute x. And when I put in y equals absolute x minus 2, again, most people think, well, plus is to the right, negative or minus is to the left on the number line. So why did this move it right? Allow me to explain. Look at your original function. Your parent function, or the vertex form, says that you take, in this case, our parent function is absolute x. So it's not h that matches up with this -2. It's actually negative h that matches up. See, this minus sign is already built in. So negative h is -2, so h is +2. So easy way to think of it here is this. Whatever sign you see on the inside, your mind's telling you if it's minus, I go to the left. Except no, it's not exactly that way. It actually goes the other way. So I guess the actual value of h is what you get, like if I had absolute x plus 3. He goes, okay, plus goes to the right. No, remember this is x minus h, so it's negative h is 3, so h is actually a negative. So you kind of have to switch the sign on it to make it make sense. So it will go left if your h is negative. It will go right if h is positive, but just be careful when I say absolute or whether I have it like as a squared function, either way. When I say +5, h is not 5. Negative h is +5. So in this case, that's one thing you need to kind of play with and make sure that you know what you're doing. How we doing so far? Is this making any sense at all to you? Okay then, so let's go ahead and practice just writing down a couple of things. So first, what is the parent function here? Well, I see an absolute value of x. So my parent function is y equals absolute x. Let's just go and fill those all in. Here, my parent function is y equals x squared. It's my quadratic. Next one is my cubic. Next one has a squared, and it's got one of those h's in it, so this one is also a quadratic parent function. Next one is your square root parent function. Again, our absolute value, our quadratic, our cubic, and then one last absolute value. So why did I make you do that? Well, by understanding what the parent function is, you can kind of figure out where it's going to go from. So if I can recognize what the parent function is, I can tell if it's a line, if it's going to be a quadratic like a parabola. Is it going to look like this cubic thing? Is it going to look like an absolute value? is it going to look like the square root function? So that's pretty much what that does for you. Now let's look at the transformations. And again, I'm going to write the transformation form or the vertex form here, which was y equals a. Remember, a does the compression, the stretch, or the reflection. F of whatever, that's your parent function. X minus h plus k. K is vertical shift. H is horizontal. So if I look at this first one, I see that I have like an a value that's a -3. So I look at it and I say, well, the fact that it's negative tells me that I'm going to have a reflection, specifically across the x-axis, and then ignoring the negative sign, the a value or the absolute value of the -3 is actually 3, which is greater than 1, which tells me I am going to have a vertical stretch, or this thing is going to look more narrow. Okay, what do I have here? Well, it looks like I just have a +4 on the end. I have a k. I have the vertical shift, so I know this is going to go 4 units up. Here, I have a cubic, and it has a -4. So again, the plus and minus at the end, that's your vertical shift. So I know this cubic function is going to go 4 units down. Okay, here I have like an x minus h squared. So it says plus, but remember h is not really 4. Negative h is 4, so h is really -4. So this is going to go 4 units left. This one again has like a square root of x minus h, and negative h is -4, so h is really 4. So this is going to go 4 units right. Okay, now this one has 2 transformations. Has a 2 in the front, so I have an a, call it an amplitude or something if you wish, but it's bigger than 1, so I know I have a vertical stretch. Technically, you have a vertical stretch of magnitude 2, if you want to be fussy about it. And then the +1 at the end is a vertical shift, telling me I'm going to go up 1 unit. Okay. Next one is 0.5. Now again, 0.5 is somewhere between 0 and 1. And it's a lot closer to 0 than this 2 is. So this is going to be a vertical compression because of the 1/2 in front. And this -2 is on the inside, so it's like an x minus h. So if negative h is -2, h is really 2. So this one is also going to go 2 units to the right. Okay, this one's got 3 different things going on. First, I have an a value of 3. Since that is bigger than 1, I know that it is going to be a vertical stretch. Okay, again, here I have an x minus h. I have a horizontal shift. If negative h is 1 or +1, then h is -1. This is going to move 1 unit left. And then lastly, this -2 at the end is your vertical stretch. I'm sorry, it is your vertical shift, excuse me. So I know this is going to move 2 units down. And the last one here also has 3 different things going on here. It has a, h, and k. Actually, it's got 4 things going on. My a is negative. It has a fraction of 1/3. I have a horizontal shift and a vertical shift. So the negative tells me it's going to be a reflection across the x-axis. The 1/3 is somewhere between 1 and 0, which means the graph's going to get closer to the x-axis. So I have a vertical compression. Okay, the x minus 2, remember it calls for x minus h. So that minus really means that h is a positive, so it's going to move 2 units right. And the plus 4 is going to be 4 units up. Now, these are skills I need you to do without the aid of a calculator. Yeah, I mean, I showed you on the calculator, but that was just to like demonstrate, to let you see what each of those parameters do. But I need you to graduate past that and then move towards, can you go from equation straight to these transformations? And I'm going to go ahead and stop this video, part 1. And in part 2, we'll actually go ahead and graph these and start doing some more, little more advanced skills. So I hope this helped you a little bit, and stay tuned for part 2.